Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P006A, which stands for Mass Airflow, MAF, Sensor Circuit Range Performance Problem, specifically for the 2023 Honda CR-V. This error code indicates an issue with the correlation between the intake air measured through the MAF sensor and the intake air assumed by the manifold absolute pressure MAP sensor. In essence, if the data from these two sensors does not align within set parameters, the Powertrain Control Module (PCM) registers this discrepancy, triggering the DTC. The MAF sensor plays a critical role in measuring the intake air mass, thus affecting engine performance and efficiency. Its proper function is essential for the engine management system to maintain optimal combustion conditions. Moreover, understanding the precise location of these sensors within the vehicle's air intake system aids in effectively diagnosing and resolving any issues that may arise. DTC P006A is associated with both the mass airflow MAF sensor and the manifold absolute pressure MAP sensor, which are integral to the engine's air management system. The MAF sensor is responsible for measuring the mass of incoming air. In contrast, the MAP sensor evaluates the pressure within the intake manifold, allowing the PCM to calculate the engine's air-fuel mixture optimally. The MAF sensor is usually located in the air intake duct, just before the throttle body, making it critical for air measurement to prevent lean or rich fuel mixtures that can impact engine performance. Both sensors contribute data used by the PCM for engine control, leading to efficient fuel consumption and stable engine operation. When the data from these sensors diverges beyond acceptable limits, the PCM triggers DTC P006A, indicating a performance issue with the MAF sensor circuit. Several issues may lead to the trigger of DTC P006A. First, a faulty MAF sensor can result in incorrect readings of the incoming air volume, causing incorrect air-fuel ratios. Additionally, if the MAP sensor is malfunctioning, it can send erroneous pressure data to the PCM, compounding the problem. Intake air leaks in hoses, ducts, or connections can also lead to discrepancies between the MAF and MAP sensor readings. This situation results in insufficient or excessive airflow being reported, affecting the overall performance of the engine. Each of these causes can lead to poor vehicle performance, increased emissions, and could even trigger other related DTCs. A thorough inspection of the air intake system and its components will assist in accurately identifying the underlying issue. The symptoms associated with DTC P006A can range from minor to severe, greatly impacting vehicle performance. One of the primary indicators is poor engine performance, which may manifest as hesitation during acceleration or rough idling. Increased fuel consumption is another prevalent symptom, as the engine management system struggles to maintain the proper air-fuel mixture due to inaccurate readings from the sensors. The illumination of the check engine light is often the first real sign for the driver that something is amiss. Additionally, drivers may experience erratic behavior in the vehicle's engine performance, sometimes leading to stalling or unexpected power losses. Understanding these symptoms enables vehicle operators and technicians to act quickly in addressing the potential causes linked to DTC P006A, thus preventing further complications down the line. In the first troubleshooting step for DTC P006A, you will begin by starting the engine in a safe environment. Once the engine is operational, you'll need to maintain it at a steady speed of 3,000 RPM without any load, which can typically be achieved when the vehicle is in park or neutral. This procedure continues until the radiator fan activates, helping monitor the engine temperature effectively. Following this, let the engine return to idle, allowing for the PCM to stabilize its readings. Keeping the engine at this RPM will help gather preliminary data regarding the engine's air intake and may provide insight into the performance of the MAF and MAP sensors. After completing this step, you should proceed to drive the vehicle while monitoring specific parameters and DTC statuses. The second step in troubleshooting DTC P006A involves performing a test drive of the vehicle over a few minutes. During this drive, it's essential to maintain a focus on the onboard snapshot parameters related to engine performance. Specific parameters to monitor include engine speed, vehicle speed, MAP sensor voltage, and throttle position, TP sensor readings. These data points collectively provide critical insight into how well the MAF sensor is operating in unison with the MAP sensor. Following this, it is imperative to check the Honda Diagnostics System, HDS, for any DTCs, particularly for P006A. Monitoring these parameters allows for assessing how effectively the intake air system is functioning, offering clues as to whether the issue is isolated to the MAP sensor, or elsewhere in the intake system. The third step focuses on inspecting the intake air system and its ancillary components. This involves examining the condition of connections and identifying any visible damage within the positive crankcase ventilation (PCV) system. The PCV valve and hose should be verified for any blockages or wear, as a malfunctioning PCV system can introduce additional variances to the air intake calculations. You should also inspect all components leading from the turbocharger joint to the throttle body to ensure that there are no leakages or obstructions. A robust intake air system enables proper airflow to the engine, while any abnormalities in the system could further complicate the DTC status and affect overall engine performance. This step lays the groundwork for checking other potential issues linked to DTC P006A. For the fourth troubleshooting step, close attention should be paid to the intake air ducts and the air cleaner housing. It is vital to verify that connections are intact and that there are no blockages hindering airflow through the ducts. Any obstruction could cause a mismatch in the readings between the MAF and MAP sensors, setting off DTC P006A. The air cleaner housing should also be checked to ensure the air filter is not dirty or clogged, as this could restrict airflow and lead to engine performance issues. Regular inspections of these components can help maintain the engine's integrity and efficiency. Following this troubleshooting step will lead to further checks on the MAF sensor's functional capabilities. In the fifth troubleshooting step, the focus shifts to confirming the operational status of the MAF sensor using the Honda Diagnostics System, HDS. Initially, the engine should be turned off during this check. You will want the HDS to evaluate the MAF sensor readings, which should normally be around 0.2 grams per second G-second when the vehicle is in a resting state. If the reading deviates significantly from this baseline, it indicates a malfunction with the MAF sensor or the intake air temperature (IAT) sensor. Performing this check is crucial for determining whether the DTC is associated with sensor failure or if other issues within the air intake system exist. Assessing the MAF sensor can significantly contribute to diagnosing the root cause of the DTC P006A error. For the final troubleshooting step, the engine should be started again, and the HDS should be employed to confirm the MAF sensor performance while increasing engine speed between 2,000 and 3,000 RPM. The expectation is that the readings from the HDS will show a direct correlation with the variations in engine speed. If the MAF sensor reacts appropriately and provides readings consistent with the increased RPM, this indicates proper functionality. However, if the readings remain static or incorrect, this suggests an issue with the MAF or IAT sensor. This functional test is vital for determining whether the sensors operate effectively under different load conditions. Completing this step provides a comprehensive view of the potential issues surrounding DTC P006A. After completing all troubleshooting steps and making necessary repairs, the next step is to verify that the issue pertaining to DTC P006A has been resolved. Begin this process by clearing the diagnostic trouble codes using the Honda Diagnostic System, HDS, which resets the DTC status. Following this, an extensive test drive of the vehicle should be conducted. During this drive, it is imperative to monitor engine performance carefully, checking for any return of the DTC P006A or related issues. The engine should ideally operate smoothly without hesitation or unusual behavior, indicating that the corrective actions were effective. This final verification process ensures that the vehicle is back to optimal functioning and confirms that the earlier issues have been adequately addressed. Preventive maintenance plays a crucial role in mitigating issues like DTC P006A from arising in the first place. Regularly scheduled replacements of the engine air filter are essential. A clean filter optimizes airflow to the engine, ensuring correct readings from the MAF sensor. Additionally, routine inspections of the air intake components can uncover potential issues before they become significant problems. This practice includes checking hoses, fittings, and the integrity of the MAF and MAP sensors. Keeping these components in good working condition enhances the vehicle's overall performance and can result in improved fuel efficiency. By prioritizing preventive maintenance, you can extend the lifespan of critical engine components and reduce the likelihood of experiencing DTCs related to the air intake system. In conclusion, understanding the roles of the MAF and MAP sensors is vital in diagnosing and resolving DTC P006A effectively. When these two sensors fail to provide consistent data, it can lead to performance issues and inefficient engine operation. Through systematic troubleshooting steps, including detailed inspections and functional checks, technicians can accurately diagnose the underlying problems and implement the necessary repairs. Additionally, emphasizing the importance of regular maintenance can prevent the emergence of such issues in the future. Proactive care, including timely inspections and part replacements, will maximize vehicle performance and longevity. This approach ensures that drivers enjoy a reliable driving experience without the interruption of unexpected DTCs. Please like and subscribe to the channel. See you next time.